Hello all, myself Venkat Tirugopal Reddy Karmuru. I am working as a assistant professor in St. Martin's Engineering College in IT department. Today I am going to explain conceptual design of an ER diagram. Let's move to the topic. ER diagram. What is ER diagram? In ER diagram, we are having the entities, attributes and relations. With the help of this, we are representing the database management system. Here we are mentioning the skeleton of the database management system. In ER diagram, we are having entity. What is an entity? Entity is an object. It is providing the properties of the particular object. So, in ER diagram, so let's have an example. So entity we are representing in rectangle. In rectangle shape we are representing an entity set. So in entity set we are having so many examples. In library management system this is the one kind of database management system. So in that library management so many events are there. So many tasks, subtasks are there. So particular task, each and everything is individually we have to represent over there. So in library management system, what are all the entities we are having in library management system? So book issue, books upgrade, adding students, so and etc. We are having these kind of entities. So in these entities we are each and entity is having their own properties. In that properties we are mentioning as an attribute. So attributes we are using we are representing an attributes is elliptical shape. In attributes, what is attribute? Attribute is a property of the object. So here we are example student table, student ID, student name, student course, so this is the database format. So here we are having the student data as student ID, it containing student name and then student course. So with this, these are all three are the attributes. So what is the relation name what we are defining here? That is student, that is an object, that is an entity. So difference, relation name we can define as entity, and objects, what are all the sub attributes over the relation, that thing we are defining as an attribute. And next, what are all the types of entity? Strong entity, weak entity. In strong entity we are taking an example of bank users. So each and every bank is having their own customers. They are having multiple types of customers. So savings accounts they are having, credit accounts, business accounts. These type of accounts are there. These are all the individually we can define as an entity. So in savings accounts, what we are perform in that savings account. So that thing here savings is an entity. So strong entity is savings account. And then in strong entity we are going to perform this so many transactions. So those are all deposit, withdraw, loan. These three types we are performing in bank account. In that bank account deposit. So in deposits we can perform through ATM, through bank. We can done this task through these two models. Then next withdraw, ATM, bank, and next another transaction type is also there. So that is the net banking. And loan will prefer only few of the customers. Not all the customers are preferring the loan amount. So many are options. So they are taking the, if they want to take the loan they will prefer. If they are not preferring the loan they will not prefer. So it is an weak entity, we can say weak entity. So weak entity we can represent by double rectangle. Strong entity we can represent in single rectangle. So this is the difference between the strong entity and weak entity. Strong entity examples are all the entities set. And next weak entity is, it is if suppose in entities we are having so many objects in that events, particularly for a bank is the one of the example. In that we are going to perform the all these steps in deposit, withdraw, loan or net banking or UPI transactions we can done through all these accounts. Savings accounts we can do, credit account we can do, business account we can do. So over the attributes. So attributes we are having the types. Strong attribute, multi-valued attribute, weak attribute. So strong attribute. So earlier we taken as an example of student table. So here we can add one more column. Student age, student ID. This is the strong attribute. So that thing we can consider here. Strong attribute examples. Student ID or employee ID or book ID and so on, etc. So in strong entity we can represent all the primary attributes. So next multi-valued attribute example. In multi-valued attribute we can use name. Sometimes we are using the some applications we are having first name, last name or first name, comma middle name, comma last name, or name of the full name. So in these ways we are representing the attribute as name. These two conditions will satisfy the multi-valued attribute. And next, this full name will not satisfy the multi-valued attribute because it is completely we are using as a single attribute. Here we are using 3 attributes or 2 attributes we are mentioning here. So that is the thing. So multi-valued attribute is based on the so many sub attributes we are going to represent one key object. And next, weak attribute. In weak attribute, example, in student point of view, we are having the student date of birth. Based on that, we can define the student age. Age is the weak attribute in student data. And next, we are drawing the student ER diagram. We are going to represent in student data. So here student as an entity. Student is an entity. So for that purpose we are representing in rectangle. So what are all the attributes? What are all the objects it is having? Student is having student name, and next student ID, and next student course, and next exams, and next student personal data. So for this we are having represent a simple ER diagram. So with an entity, one single entity, and then next over the all the objects we are representing with the attributes, and then later we have to add the weak attribute and next multi-valued attribute for this diagram. In ER diagram we are going to add. So for course purpose we can set as course. It is another entity because in course in a college they are offering to so many branches. So for that purpose I have to assign course ID and next course name, the connection between the course and student. So this is student will enroll with only one course. So here we can say student to course we are connecting the line. So that thing is an relation. So in this course ID we are having only one. Course names we are having so many courses are they are offering in college. So for that purpose next we are going to add student is an entity, and next course is an entity. Next, here we are representing an relation, condition. We are verifying the condition. What is the common thing? So, for verification of course, if the student was finished the course, we need some results or certificates. In that point, they have to write their exams. So student will approach examination branch and then over the registration process, and then they are writing their exams. Course, based on course they are verifying the conditions and all. Who are the enrolled with the examinations, for them they are giving the registration process, and then later they release hall tickets. So they are writing their exams with validation. With their hall ticket only they are entering to the examination hall. Then they are writing their exams, and then later examination branch again releasing the results. So here the connection between the all the entities, and then one attribute, because the students are enrolled with their exam registration process, and they are writing their exams with admit card. It is an hall ticket they are using. So here for student point we are having so many attributes. In course point we are having some attributes. In result point, here also we are having some different objects. So that is a regular result, supplementary result, and then they are having revaluation. So these operations we are performing on the examination branch. They are first verifying the data who are registered with the examinations, and then they are cross verifying which branch student are enrolled, and then they are releasing the hall tickets, and then students are writing their exams. And then results. So after writing of examination, they are getting the results. In results point of view, they will get the results at regular time, and then some of people are having their supplementary exams, that for that they are having the supplementary result, and then revaluation. If any student is having any kind of obligations over the result, then they are going for revaluation. And next, so in AR diagram, we are checking the clear data models. So conceptual design helps to define the clear and consistent data models. Here we are representing the data as a clear manner. Whenever we are going to given the some data to some other person, it has to be in readable format. And then next, improved communication. So communication, for some students will want their registration purpose in some other events in college fest or like that is going on. They at that time they want improve their communication, so we can't provide from department side, they can't provide the full details of the particular students. So for that purpose we need to trim the data, we need to cut the data whatever the data is required to the particular event coordinators. For that we are providing the small amount of data. So in AR diagram, facilitating communication among the stakeholders, allowing everyone to understand the data structure and relationships. So these things we are going to do in communication purpose. In reducing errors, conceptual design helps to identify the penalty errors and inconsistencies. So these things before actually database is built, saving time and resources. So for suppose we are having some large volume of data. In that data, we need to identify the students. So for that purpose, we are using their unique IDs. Then whenever we are using the unique IDs, we are retrieving the data. So if the student was having multiple participations in the event during his education time, so or during the pursuing their undergraduation, at that time he can involve in first year, second year, third year, fourth year. So these all the 4 years, the particular student participated in so many events. At that time, when we are retrieving the data, so particular events, if maybe he is having the same event on first year, second year, third year, when we are requiring the particular year data, means we need to mention we have to give the input to the particular condition. Based on that condition only we are going to verify. If we are not given that data, means it will display the all 3 years data. So that will not good at all. So next, enhanced data performance. So here we are optimizing the relationships. So relationships, in relationships in ER diagram, we are having one to one relation, one to many relation, many to many relation, many to one relation. These 4 types we are having. So we are going to discuss with. So we are having the 4 type of relationships: one to one relation, one to many relation, many to one relation, and many to many relation. In one to one relation, so one student will register one course only. Example, student will register only one course. So that is the one to one relation. In one to many relation, example, student will study so many subjects in his course. Many to one. Example, in many to one, we are having the relation between so many will opt the one branch. So one course, students will select one course. And next, many to many. Example, many to many. For suppose any kind of technical events are going on, so that means so many events are going on in that fest. So students will register multiple events. Multiple events. So here the Examples clearly. Student will register only one course only. So and next one to one means one relation between another. So for suppose we are having the Venn diagrams. So 1, 2, 3. A, B, C. When we are going to say one to one relation means this in this entity is linked with another entity, one object. So these are all objects will involve having connection between only one on one. For one to many. So same example we can consider 1 to B and 1 to C. One is having the relation between A, B, C, and two is having B only, and three is having C only, and two and three are having only one to one relation only. In and one is having one to many relation. In many to one. So we can consider another 1, 2, 3. A, B, C. A is having the relation of 1 and 2 and 3. Here A is having the connection between the all the three elements in set A. So this is the many to one relation, many to many. So we can consider set 1, set A, one is having relation between A and one is having relation between B, one is having relation between C, two is having relation A, two is having relation B, two is having relation C, three is having relation A, three is having relation B, three is having relation C. So many to many. So each and every object having the multiple relation between the each object. So this is the four conditions of relationships. So first one to one relation. One to one relation example is student will register only one course only. And next one to many. Student will study so many subjects in the course. And next many to one. Student will select only one course. And next many to many. Student will register multiple events in particular event time. Particular event time. And next, let's watch one sample video over the topic. So here diagrams. Here look. Here look once. So here they are specifying the what are all the components are existed in the ER diagram. So entity, weak entity, strong entity and weak entity. Attributes. Attributes are having single strong attribute, multi-valued attribute, and next derived attribute. We can say weak attribute. And then relationships. One to one relation, one to many relation, many to one relation, many to many relation. So entity we are representing in rectangle. And next weak entity, bank account. Attributes. So attributes we are representing in elliptical shape. So we are having already attributes Strong attribute, we multi-valued attribute, weak attribute. So dotted ellipse means weak attribute. Multi-valued double ellipse means multi-valued attribute. Single ellipse means strong attribute. So whenever we are representing an ER diagram, so what are all the events, sub entity sets? For suppose in entity sets we are having all the entities and attributes. So these are all the concepts we are using in ER diagram. So thank you for giving this opportunity.